Okay, today we're learning about special relativity. First thing we'll do is define some definitions. So very important for special relativity is the relativity in general is the idea of an event. This is any occurrence with which a definite time and a definite location are associated. And this is actually an idealization. It's any event bound to have either a finite extent both in time and space. So nothing can ever be we approximate the infinitesimally small window of time and space, but it is an idealization in that sense. A frame of reference is another important concept. So this is a set of coordinates or perspective used to measure the position and motion of an object. It consists of an array of observers all at rest relative to each other, stationed at regular intervals throughout space, and the coordinate system moves with these observers so that the x, y, and z coordinates of each observer are constant with time. The observers carry clocks that are synchronized, and each observer records all events at their location. Each event has four coordinates, the three spatial coordinates, which are inherently just the coordinates of that observer that takes the measurement, and the time at which they made the observation. A second frame of reference would consist of another array of observers, all at rest relative to each other, and all moving with the same velocity relative to the first set. So that's a very important requirement for special relativity, that the observers, for these equations to work, the relative velocity between the two sets of observers has to be constant, so no acceleration is going on. It becomes a lot more complicated when that happens. And also the coordinates of a given event in two frames of reference are in general different. Because if I'm standing on the ground and measuring the motion of a person walking through a train, I'm going to take different time, x, y, and z coordinate measurements compared to someone who's on the train with the person, who are within the same frame of reference as them, but on the train's frame, from the train's frame of reference, and I'm from the ground's frame of reference. And the central problem of relativity is to determine the relationship between these two sets of coordinates. That is the problem we're trying to figure out when we're talking about relativity. So some important notation, because we're comparing two different frames of reference. One frame will be called S and the other will be called S prime. So coordinates in S prime will be designated with prime symbols, while the coordinates in S will be designated unprimed symbols. So events will be labelled E1, E2, E3, etc. And those events can span across different frames of reference, and thus you could have x prime 1, y prime 1, z prime 1, and t prime 1 denote the coordinates of the event E1 measured in the frame of reference of S prime, whereas x2, y2, z2, t2. Notice how these in the second, there should also be there should probably be a t there as well for the temporal coordinate, but they represent coordinates of E2 in S, and notice how they're unprimed because they are from the frame of reference of S, the unprimed set. And obviously the description of a frame of reference as an infinite array of observers is an idealization and a literal description of how measurements are taken out, because just infinite observers throughout a evenly spaced throughout a set of coordinates, but that's just a good thought experiment to think about how measurements are being taken.